My name is Jakub Kramata, and I'm senior data scientist. And when I speak in front of people, I move a lot. So sorry about that. Hopefully it doesn't bother you too much. If you don't understand anything I say, just ask me. You don't have to wait till the end. You can also ask while I'm presenting or talking. And when I was setting up this talk, I was able to hide this taskbar. Now, for some reason, it's again here. So I'm sorry about that, but we will have to live with it. OK. I am a senior data scientist, as I mentioned. Michael already introduced Adam team. We do lots of things. We do machine learning, deep learning, artificial intelligence, as everybody does nowadays. And we also have been migrating to the cloud for the last 2 years or maybe even more. So it was a long journey. It wasn't easy. And one of the things that I want to introduce you today is our road, how we handle our migration of our data and how we check that our data are OK. Yeah. So let's start. First, I will start with our original situation. So this is where we started. On the left side, from your point of view, you can see our data warehouse. On the right side, you can see our data storage, Teradata Aster, which is a relational database. And it contains a subset of data from the whole bank data warehouse. And we use it as our data source for our analytical work. And it was optimized for big data. It worked quite well. But unfortunately, Teradata have decided not to prolong support of Aster, no longer supported. So we needed to change our stack. And we decided to move to the cloud. Because it makes sense. If you do data science, the cloud is always the answer. At least now, we will see how this will change in the future. But so we decided to go AWS, and our situation was, OK, we have data here, and we need to get them there to the cloud, of course. How to do that? Well, we decided to hire a team of Indians, and they built ingest. So we have a custom ingest. But what is important in data science and in data generally, you have to believe in your data, and you have to believe that your data are OK. Yes. And we have to find out the way how to make sure that our data, when we send them to AWS, are OK. So we had a discussion, and there were two possibilities how to do that. One of them was calculate aggregate metrics over the tables. And another one was calculate checksums. Yeah, we decided not to do checksums because we thought it will be too heavy on resources, and it will take too much time to calculate checksums for files or for each row or for each column. So we decided at first, let's calculate metrics. Let's calculate them over the tables on Aster and also over the tables in AWS. What I have to say for the context or the whole context, on AWS, our data are stored on S3. So one word is relational database. Second word is object storage, where you have files. And instead of direct connection between databases, now you are sending CSV files. One of the things that we needed to do, we wrote a Python code that calculated these metrics. And one of the things that we have to do was check or translate data types between both words. One of the things that we use in cloud for the data, before we were using SQL, now we are using PySpark in cloud. So we needed to match the data types. And then we calculated these simple metrics. Yeah? We calculated number of rows. We calculated number of unique values. We also calculated number of nulls, min value, max value, and summation value. In this case, you have to handle different data types, so the whole solution was much more complex, but it wasn't interesting, at least not that much. I should present it to you. So this was our original idea. But then the reality was that we sent one file, it was okay, and then we sent second file, and unfortunately, it was completely broken, and it didn't work out. Yeah. We sent third file, and it was also broken, and the data were completely messed up. So one of the problems that we see or saw was that files were broken too often. Some rows were missing, values in columns were mixed. That happened also often. The decimals were wrong. That was another problem. Sometimes they were too long. Sometimes they were rounded, even though we didn't want to. And another problem was that we have we were able to check only one data source, but we weren't able to check multiple data sources because we wrote a solution that was possible to run or calculate metrics only on Aster, but not anywhere else. So this was obviously the wrong decision, and we have to go back, and we decided to calculate checksums. Now we move from Aster, and we focused on CSV files. There was a change in the whole concept, and we decided to calculate checksums for each row in the file, and also then when it's stored in AWS on S3 as a Parquet file, we decided to calculate checksums also there, and then compare the hashes and find out where are the differences. So we created a solution that is called SumChecker. The name is slightly confusing because I thought, well, to be honest, I just mess up the words. It should be checksummer, but I make a mistake. I made a mistake, and it's a SumChecker. We call it internally SumCheck, and it's solution written in Python, and it just take a row, hash it, save the hash, and then it is able to compare it. I will give you a, let me just click on these. Now it consists of 4 parts. One of this is AIML runner, another one is Anderson runner. Now, then we have a row hasher, and the last one is hash checker. AIML is our Linux server where we take the CSV file immediately after it's generated, and we calculate hashes. Edison runner, the whole project of migrating to the cloud is called Edison. So this is runner that runs in the cloud. Row hasher is a class that is calculating hashes, and hash checker is just comparing the results and tell you what is wrong and what is okay. Yeah, this is something that we needed to solve also because you are comparing 2 different type of files. One is CSV, another is Parquet. The huge difference is that CSV is easy to generate. So it was decided that we will send our files or our data in CSV files for that reason. You are able to generate them almost everywhere, and they are easy to share. One CSV file is also easy to read, but if you have multiple different CSV files from different sources that have different formatting, and also these files have metadata that are wrong or corrupted, then it's a nightmare. And that was the most challenging thing about SumChecker. On the other hand, Parquet files are easy to load, are easy to work with if you have proper tools. PySpark, Pandas are able to handle them pretty easy. easy. And they know about data types, so they are fast. On the other hand, CSV files are really slow. They are basically just strings, as you probably know, and they need to be processed sequentially. Yeah. So another thing that we have to, another thing that we have to handle was how to work with them. This is what I'm showing you is a real code. It's a template that I used in both Edison Runner and IML Runner. And there are basically 4 parts: read data, prepare data, hash data, write data. They are self-explanatory. What I think it's interesting, because when you create hash, you also have to identify the row to be able to find out when the hashes doesn't match, why they don't match. And for that, I decided that some checker should be able to define columns that are primary keys columns, and they should be added to the hashes. So basically, the output of the whole solution is hash and some primary keys that enable you to set up the output, and then compare the outputs of the both words and decided where was the error. Yeah. Also, you can, if you don't have primary keys, you can decide to take only first 2, 4, or 6, and it's up to you how many columns you will add, first columns you will add to the output. So it's the parameter output size that you can use for that. Also, you can, when you're creating data file, you can set up the name of the data of the final file. You can create prefix, suffix. You can decide where should be stored, of course, or you can set up the whole name by yourself. So the whole solution was really general and should handle all the possibilities that we could map. The framework that we decided to use was at first Pandas. We work with Pandas, but unfortunately, when you have hundreds of files that are more than 20 or 30 gigabytes, then you find out that Pandas is not a great solution for that, because in our case, it took about 4 times more RAM memory than the file original size. So we decided to try anything else. And because I had that experience with Dask, and in the past I was quite happy with it, I decided to use Dask. And Dask was a great solution because my first version of some checker was written in Pandas, so it was easy to transform or rewrite it to Dask, because in backend Dask is using Pandas, and thanks to its lazy evaluation, it was quite much better in handling large files. On the other hand, what I really hate about lazy evaluation is debugging. Yeah. I will get to it in the next pieces of code that I will show you, but debugging in Pandas is much more straightforward. In Dask, you have to work with the query plan. You have to see how the resources are distributed when you do calculations, and it's not that straightforward. It's not that easy. The logic question is, why not polars? Nowadays, polars are really popular. The answer is simple. A year or year and a half ago, it was quite new framework, and I wasn't convinced enough that they would be that better than Dask. Today, I would use probably polars because they also create a query plan. They are also lazily evaluated, but at least as I heard, they are able to optimize the query plan much better way than Dask is. So now I will show you some code and how the whole solution is constructed, at least the interesting parts. I will start from the inner functions and go to outer functions, because even though I think it will make more sense than the other way. So the final hashing part is just a simple algorithm FNV hash from FNV hash library, and the algorithm is called FNV1A, sorry. And the decision why I choose this algorithm is because it's really fast. It's quite fast thing. We were able to beat it in C, but only slightly. So you run this algorithm in Python, and it's almost as much as fast as solution written in C. So the results is pretty much amazing. As you know, Python is really slow. For that, I also needed to just what I'm doing here is that I'm taking each row of the tables, I transform it to the string. So no matter the data types, it's always the string, because then I hash it. What I'm working with here is Dask data frame. So so I take Dask data frame, it's distributed, I take each row, hash it, and then sometimes I even add some columns to it, to the output, as I mentioned before, and then you get your result. So this is hashing. Now before that, you have to sort the columns, of course, because you cannot be sure that somehow the columns are not intertwined, and that the order of columns is changed during the ingestion process or when the data are generated. And also, you have to call the function over all partitions. So this is basically what I did. What is interesting, Dask has this meta parameter when you have to, when you can provide metadata to the Dask how to handle the output. So I'm telling here that the header name is a string. Now, one of the pre-processing I also did is rounding and filling missing values or unifying missing values. That was another problem I met during writing the solution. One of the problems with missing data is that Pandas by default, because Pandas API were used by Dask, Pandas is translating some strings as missing values. So it was complication. We had a situation when someone wrote null into the message, and it was recognized by Pandas as a missing value. Fortunately, you can turn off these values that are translated by Pandas as a missing values. You can turn off and provide it only yours that you want to be translated. And also, I needed to handle different data types, because typically integers cannot work with missing values, so I work Pandas integer 64 because some columns that we use and are integer types contains missing values, so you have to have something that is able to work with it. So this is some also why these lines are separated, because my original idea was that I am going to round different data types differently. But after some experimenting, we find out that in the words of money, which is bank is working with money, 2 decimal places are more than enough. Yeah. So, and again, I will call this function over all partitions. Another thing is reading CSV, because reading Parquet file is quite easy. There is nothing that you can be worried about. It's work easily. Yeah, it's quite simple. But reading CSV, as I mentioned before, can be a nightmare. And I have to do 2 steps. At least I wrote it that way. One step is this simple function that will read data frame. You can set up all these parameters. But what you need to do is, because it's lazily evaluated, then you will need to be sure that everything will run as you want to, that there is no mistake as soon as it's possible. Because if you wait till the end of the calculation, if you wait when the code is called and processed, then you can wait for, I don't know, 20 minutes and then find out that there is an error. So I will just, this simple action when you trigger the code and over few rows, you will find out pretty quickly whether everything is okay or not. So this was quite helpful, even though it's quite simple, it was really helpful. And also what I needed to check was that even though you are able to read a CSV file, sometimes it's not properly parsed. Yeah? You can have some columns smashed together, some columns are separated, so you have to check the number of columns. And because we have metadata, then you can take the expected number of columns from the metadata and then check the real number of columns and compare them. So that was another thing I had to do. And if the check is not okay, then you raise parse error. This inner function is handled by this for loops. I know that for loops I hate it, but in this case it's pretty readable and pretty useful. You have to go from these parameters that were because, as I mentioned before, CSV files can be formatted in different ways, and what is troublesome that sometimes even metadata that we were provided doesn't match. And then you have to find out the way how to load the CSV file, because otherwise you cannot compare anything. You're just not able to read them properly. So I take the in config file, you have these parameters, and you go over them, and you go over all possibilities that you have, and you try them. And when it's failed, you go again and you try another combination. And this is what SumChecker does. It goes through all combinations that are possible. And as you can see, in case of separators, the separator provided by metadata is a first option, and then are added separators from config file. But still, I try also not only the combinations from metadata, but also the separators from config file, because you cannot trust anything. And that's it. Then you try to read the files, and when you succeed, you can compare the files that you get, or you can compare the hashes that you get from CSV files with hashes that you get from Parquet. I won't show you the code about Parquet because it isn't interesting. What I think, even comparison of results is not interesting. It's just they are just joins. It's nothing that's needed to be presented in any way. So this is whole solution basically. These were the interesting part. This is it. This is just the thing I was trying to do animation, and I wasn't successful. And I promised a commit, but I find out that all of my commits are boring, at least on this project. But well, this was the best one I had. So that's it. That's it from my side. That's all the presentation. Now it's time for your questions, if you have any. So thank you for your time.